as I said, chapter 1 is almost done, except for the fact this is conversion. This is very confusing when it comes to the conversion. And as I said, it is, take the blue color. So we have from English to English, that's straightforward conversion, correct? English to English, the straightforward. And you can print out, because this is an open book, you can print out a chart of those all conversions. You like whatever I put, that's fine. You can Google one and print it out, keep it handy to you. But the problem is when it comes to metric to metric. So let's put this one here. Metric to metric is the most difficult part. Metric to metric. And I think I put this one here in iCollege. Let me just look at iCollege. I think I put an announcement, one of those long time ago. I hope I have it here so I can show you this table. I mean, if you like it, that's fine. You can use it. If not, you can use your own. You print your own, whatever you like. But the main thing is you need this conversion table. I say that because in the final exam, you don't have to memorize all this unless there's a very simple ones. But any difficult conversions, it has to be given to you. This one has to be given to you. Let me just go for the conversion. I don't see conversion, but if it's not there, I will put one for you here. And I think maybe in the lecture. So I'll put one for you in the announcement. So don't worry, I'll put for you one. So the main thing is you have to know those metric exponents, the whole thing there. And I think in the lecture we went through this one here. Suppose I'm doing now 2.5. Let's do this one here. 2.5 pico and gram. We'll convert this one here into say gigagrams. This is the mass conversion, and we want to see how much is 2.5 pico, small p, gram to capital G. So the main thing is you have to have this chart in front of you. Pico is 10, but what? Negative or positive? Somebody will look it up. Negative. How much? 12, correct? And giga, how much? Positive or negative? Positive, how much? 9. Okay, so that's I can't help it. You have to print out the chart. So you have to print that chart, make it handy to you. So you can make a chart handy to you, and then you know all those prefixes of the metric system. Can you see or you can't see? What it says here? What it says? Chapter 2. Let me see what's happened here. I see what's happened. I have to put it duplicate, so now we see. Okay, sorry about this. So we talked about metric to metric, and we said that's one of the most difficult part because you have those prefixes, the exponents, and as I said, I'm not telling you to memorize those. You have to have the chart in front of you, and so you can convert those together. So if I have the values, then it's easy to convert. So now it's really easy to convert. So I know the value of the pico, and I know the value of giga. So I say it's 2. I have to go through the basic units, picogram over 1. And then I have the unit 1 gram here. And the pico is picogram. Remember, that's 1012. So I have to put in front of it, oops, sorry. It should not be that's thick. I have to put in front of it value, the opposite to the exponent. So the exponent p is 10 minus 12. I put what? 10 plus 12. Why I'm putting this? Because if I multiply the p value with this value here, I come 10 plus 12. 10 minus 12 makes 10 power 0, which is 1, which is equals to this. Correct? Then I go further here, and then I say, okay, I go to the basic unit, 1 gram, and then I have gigagrams. So gigagrams, this is, we say, 10 plus 9. So I put in front of it what? Somebody will tell me? The opposite of it, 10 minus 9. Can you see it now? With this in mind, then we have, let's look at this. Gram with the gram cancels out, correct? And the picogram with the picogram cancels out. The only unit left is whatever we are asked for, gigagrams. So then that will be 2.5 multiply over 1, multiply 10 plus 12 at the bottom. I want to take it up to add it up to the 10 minus 9. So that will be from 12 plus 12 will be 10 minus 12 over 1, and then 12 minus 9 over 1. So the answer is 2.5 minus 9 minus 9 and minus 12. How much is it? Minus 21 gigagrams. This is the answer, and I'm keeping my sig fix to sig fix. I did not change the sig fix. Okay, guys. Another example, correct? Let's do another example. That's the first one here. Are this following? As I said, that's the most difficult part of the conversion, because you have to recall all those prefixes of the metric system. Okay, let's take another one. I'll take the length. Can I take this one out? Everybody has it? You can take a picture of it. You can record me. You can, whatever you like. Please feel free. So, can I take this one out? Okay. So I'm taking this one out, and then I will do the length. So then we'll do the volume. So 2 examples more. So let's convert 8.731, and then we'll n meter, correct, to make it a little bit difficult. Can we make it difficult a little bit? Okay, so DC, that's DC, not deca, that's a DC meter. That's a DC. I think I have the chart. Just bear with me a little bit. I'll show you this. I think I put this one here in the just to make sure that we are in the same. Because if you get this one in hand, then it will be very easy to follow everything. So let me take this one here out. The lecture here, if you look at the PowerPoints, and just quick here, just quick. Yeah, here it is. Yeah, let me just minimize it, and then what I will do this. Let's take the DC out of the way, so I can put this one here so you can follow me. So let's take the DC out. That's a DC, correct? But I'm using my snipping tool. Remember the snipping tool at the bottom to snip this chart here, which is very important to us. So I'm snipping this one here and keep it here. Edit, copy it. Edit, copy it into our problem. Now we'll print it here, and we'll go down. Let me go down a little bit. Okay, down a little bit. So now when you review this, then you will have the idea is to look into those. Let me just give it to you. The more spacing here. Layout is 5. So here it is. Get to you so you can see it. Okay, guys. This is I found in the internet. You can print this one out if you like it. If you don't, please feel free to use your own. So Deca DA. So the difference between DC and Deca is DC is D, correct? So now here I'll come back and use it is D is DC. DC is how many is the power? 10 minus what? 1, correct? It's here. 10 minus 1. And the nano, 10 minus, nano is from the Greek and Latin is 9. Nano is 9. Nano means 9. So this is correct. 10 minus 9. Now we are going from 10 minus 9 to 10 minus 1. Can we do it together? So this one will be in the lectures, so you can, when you look at it, that's in icon in the PowerPoint of chapter 1. If you like it, I like it because it's easy to follow. But, I mean, there are other charts as well, so it's up to you. But the main thing, you have to have one of those charts like this handy because you don't have to memorize all those, all this. Where is the, if I ask before I start, it said the highest is Exa. Is this the highest? What's the lowest value here? 10 power minus what? 18? Do we have lower than that? Yes. So it goes up to 10 plus 24 and 10 minus 24. 10 minus 24 is the mass of an electron in the atom. We'll come back in chapter 2 to talk about this. So 10 minus 24, but beyond 10 minus 24, we can't get that because that's electron. That's the smallest unit ever in the atom itself, correct? So, but from calculation, math-wise, yes, we can have 10 to minus infinite, so we can have this value here. This value can be existent, correct? Infinite value. But for us, for the practical one, we can measure is this one here. This is the mass in grams of an atom itself. So let's convert. Let's go here and look. I'm looking for DC, not a deca. Deca is DA. So deca 10 plus 1, the opposite. Deca 10 plus 1. And deca means Latin is 10. You can see this deca is 10. So decimeter, that's required for the conversion. So we'll start whatever is given to us. We'll keep everything as intact. That's 4 sig fix. This is nanometer. So you tell me what the next step is. What's the next step? I have to go through the basic unit. The basic unit of the length is 1 meter here, 1 meter in the top, and I have to cancel the nanometer here. The nano, we say 10 minus 9. What should I put in front of it? 10 what? Plus 9. Correct? What should I put in front of it? 10 plus 9. Correct? The opposite of the prefix exponent. Nano is 10 minus 9. I'll put in front of it 10 plus 9. Because if I multiply this by this, 10 plus 9 multiply 10 minus 9, 10 power 0, which is equal to the 1 here. Correct? Next is to get rid of the basic unit meter, and I'm looking for the decimeter. Decimeter is 10 minus 1. What should I put in front of it? What should I put in front of it? 10 plus 1, correct? So then I come with the cancellation of basic units. So nanometer with the nanometer cancels out. Meter with the meter cancels out. The only left unit is whatever I'm looking for. Decimeter, correct? So that will be 9.731. I did not touch anything of the sig figs. Those are 4. 1 over, I have, this is the bottom 10 plus 9. I will take it up with the opposite sign. 10 plus 9, 10 minus 9 over 1. Multiply by 10 plus 1, and the unit is this decimeter. So that will be 9.731. 10 plus, this is came out plus, this is minus, correct? That's plus here. Minus 9 plus 1, how much is it? 10 minus what? 8. And the unit is decimeter. So now you'll not find this one here anywhere. This is my own, through the years, this is my own way to solve those problems. I know you did in the past with these zeros going to the left. Remember, the high school 0 goes to the right. And if you have too many zeros, then the error will be, most probably will be there. So this is the answer. Let's take the volume. Let's take another example, and then we'll call it up for chapter 1. Any question, please raise your hand if you have any question, please. Yes. What's that? -8 dm, decimeter. Okay. Any question you have, raise your hand. Don't be shy. Yes. What's that? Yes, that's you have at the bottom. Look at the bottom. What we have, the power is positive. When you take the power from the bottom to the top, you have to swap its sign. That's the rule. Anytime I take any power exponent 10 of whatever value, whatever is sign, when I swap it up, take it up, I have to swap its sign. It's plus 9 at the bottom, so I take it up as minus 9 in the top. Yes. Yeah, if it's positive, it's positive in the top, I pull it down, it will be negative. You have, whenever swap any exponents up or down, you have to swap its sign. Are you following me here? That's part of the scientific notation. So, any other question? Don't be reluctant or hesitant to ask. Please ask. I'll be happy to answer any question. And as I said, this is the most difficult part of the conversion. All the other conversions are straightforward. It's not really difficult. So let me take this one here out and look at, oops, sorry, you have to tell me, so I'll wait. So you have to tell me that, okay, wait, I will wait, so you can take. So I'm taking this one here, or we can keep it as so you can look at the example here. So now we are looking at the volume. So convert, so I will say 8.12103. We have about, how many sig figs we have here? How many sig figs, guys? 6 sig figs. And what type of prefixes you want to use? From what to what? We will be using liter as a volume, unit metric. We are in a metric, we use liter. But what prefixes to what prefixes you like? From lower to higher, higher to lower, what you like? Somebody will tell me? Any preference? Any preference? Lower to higher? Lower to higher, what's lower? So you have a deci to whatever, vimto, atto, whatever that really is. We don't really use. What really we use up to here, pico to deci, we don't use those very often, those 2 and 10 minus 24. We don't use that. So, and here to up to here, that's what's really used. Those two are not used, but we can use anything. So anyway, so from lower to higher, what you like to use the lower one? Again, we are using L, liter. This is liter, volume. This is liter. What you use? From lower. Lower is here. That's lower. This is lower exponents. So what do you want to like? Micro, pico. We took pico, we took nano. Macro, okay, macro is nano is n, macro is mu. This is a Greek way of saying this is macro. It's a mu called mu. That's a Greek alphabet. Mu. This is the macro is you can see macro 10 minus 6. So macro is this is macro here, and this is 10 minus 6. It is, where is this macro? Yeah, 10 minus 6. Into what? Into what? Now, we'll take higher. You said higher. Which one higher? The higher is always used from tera up to deca. Those deca to tera, those are the highest positive exponent. Which one? Somebody will tell me which one? Giga? We took giga before. Mega? Well, that's okay, mega. So mega capital M liter. Okay, guys? Mega is the opposite. 10 plus 6. Correct? And in the commercial businesses, mega is what? Equal to what? Come on, guys, don't let me down. Equal to what? 10 power 6 is million. That's million range, correct? 10 power plus 9 in the commercial. What is that? What is that in the commercial sense or businesses? 10 power 9 is billion, correct? 10 power 12 plus 12, how much is it? Trillion, correct. So you have to know those are some units are used for commercial businesses or for commercial purposes, and therefore scientific. We don't say for scientific 10 plus 9 is trillion. We don't say that. That's in the commercial purposes or businesses, whatever commercial stuff you are dealing with. But that we call tera, giga, mega, kilo, hecto. That's what we say. So let's do the conversion. So we are looking for this mega. The basic unit is liter, question mark. We don't know how much that really is. We put the number as is. We don't touch the number with all its significant figures. 6. And we have to put the units is mu liter. So that's the unit is, correct? That's the unit is. Macro, 10 minus 6. And then we have to get rid of the macro. Let me take this one here. So we can okay, so we have to take the macro out. We have to take the macro out. Here it is. Macro or mu, not macro. This is a macro, but it's called mu liter or macro liter. So and going through the basic units of the volume metric is liter, correct? Now mu here is 10 what? We say 10 minus 6. What should I put in front of it? 10 what? Minus 6 or plus 6? Plus 6, the opposite. Correct, perfect. So then I have to get rid of the basic unit, correct? And then I'm looking for megaliter. Mega is 10 power 6, correct? What should I put in front of it? 10 minus or plus? Come on, guys. Mega is 10 plus 6. Should I put what? The opposite of the value, correct? Of the exponent. So 10 minus 6. Everybody's following me here? So now we take unit cancellation, the next step. Macroliter out, liter out. The only thing left is our capital M megaliter. So now here is 10 plus 6. I have to get up, swap it to the top. That will be 8.12103. over 1, no units, we cancel the units. And this is 10 plus 6 will be 10 minus 6, correct? And this is, as came 10 plus 6, came out 10 minus 6 megaliter over 1. So the answer is, the answer is guys, here is 8.12103. 10 power what? Minus what? 10 power what? 12 megaliter. 10 minus 12. Minus 6, you add them up, correct? When you multiply exponent, you add them up. When you divide exponent, you subtract, right? So that's the answer here. I did not touch anything of the sig figs. It's as is, correct? Now that will be the end of chapter 1. I want to go for chapter 2. Any question you have? Any question you have? That will come in the quiz, yes. That will come in the exam, yes. And the final exam, yes. They might give you some small tiny ones, kilo to whatever. But before I finish this chapter, let's look at sometimes in the SS exam they bring you between English and between English and metric, or between English and the SI system. So can I take this one out? Take it out? Okay. Let's put something here, and I'm taking this one here it's out. Let's put now between English and take from English. I'm taking the English one. It is, guys. I'm going for the English to both metric and the SI units. So the length, for example, I have 2.50 miles. And I want to get this one here. I mean, with the same metric and SI, they are really almost overlapping each other when it comes to the length. So how much is this one here in miles? Into what? Centimeter. That's a metric, correct? And the SI sometimes will adopt this meter and kilometer. It's the basic unit in SI kilometer, but it will adopt those centimeters. So you have 2.5 miles and want to convert them into, this is an English system. And this is a metric system. So this one here, I need help from another type of chart. I need a chart that gives me the whole three systems together. Again, you can Google it out. Feel free to print it out and keep it in front of you so you can follow that those charts here. You don't have to memorize. So I need centimeter. So what do you think the value will be? A centimeter is just, an inch is 2.54 centimeter. So if you have 2.5 miles, that will be a lot of centimeters, correct? The distance will be a lot. So 2.50, oops, it is, guys, 2.50 miles. I'll say mi over 1. Then I have to go through the basic unit, but we don't have a basic unit because we have a conversion between two systems, two measuring systems. We don't have a basic unit here. We have a basic unit for each. So I will say here I put a mile, 1 mile. Then I have to put 1.62 small k meter. Correct, guys? Are these following what I'm doing? Now I transfer this one here into the SI system because I'm using the kilometer, which is the basic unit of the length for the SI system. Now, With this, I have gotten rid of the miles with the miles out. Now I have the problem with the kilometer. Then I have to go to the basic unit of the metric is 1 meter, and kilometer at the bottom, correct? K is what? From the whatever the table, 10 power what? 10 power what? 3, correct? Kilo power 3. So what should I put in front of it? 10 what? Minus 3, the opposite. But I'm not looking at the meter, I'm looking centimeter. So I would say further, one step further, 1 meter at the bottom, 1 centimeter at the top. C is 10 minus what? Kilo is 10 plus 3, that's a kilo. Centimeter is 10 minus what? 2, correct? So what should I put in front of it? 10 plus 2. You get the idea? Very comprehensive, 4 steps. 4 steps. You cannot go, less than those steps. But we need this one here, the metric and the English system, you need this one here from a table, special chart. What's the relationship between the metric or the SI with the lengthwise with the English system? That's you need it. This is only what we don't know, so we need a special chart for that. Correct, guys? So now, looking at the whole thing here, I wanna do the whole thing. So this one is already up. Okay, this is the only unit left because the kilometer with the kilometer cancels out. The only thing here is this one here. Meter with the meter cancels out here, correct? Is 10 minus 3. What should I put this one here? Take this one what? Up. I have to take the 10 minus 3 up. So the answer is then, let's look at the answer here. I have, make it smaller here, so they'll fit 2.50, sorry, over 1. This one is 1.62 over 1. The top here is, let me just put this one. This one here, multiply by 10 minus 3, 10 plus 3 in the top. And in the top is 10 plus 2 centimeter. Okay, guys? So you have to multiply 2.50 multiplied by 1.62, and then the power 10 plus 3 multiplied by 10 plus 2, 10. So the answer is, let me multiply here, guys. Just give me some time here. I'll multiply here. 1.62 multiplied by 2.50. It's 4.05. So it is 405. 10 power, how much? Plus 3 plus 2 makes what? Plus 5, correct? Centimeter. That's the answer. Everybody's following me? Everybody's following? Any question? That will be the end of chapter 1. Any question you have? Put any number for yourself and put whatever from higher to lower prefixes in the metric and see how much, or put some metric to English to metric. This is the length. You can take the mass, which is with how many pounds, and then how many milligrams, pounds to milligrams. So metric to English to metric and so on. So that will be signal the end of chapter 1, and I'm closing this one here. Stop the